Hello everyone, this is Sriram. Today I will be presenting our work, PRIMEDrive-CoT, a precognitive chain of thought framework for uncertainty-aware object interaction in driving scene scenario. In autonomous driving scenarios, traditional methods struggle with complexity and interpretability trade-off that often rely on deterministic models which fail to capture probabilistic nature in real-world scenarios. High-risk situations such as autonomous driving are inherently probabilistic, where precognition, the ability to anticipate and interpret complex situations in advance, plays a pivotal role. Human drivers naturally assess upcoming risks based on contextual observations. Replicating this ability in autonomous systems requires models capable of uncertainty-aware interactions, risk forecasting, and proactive decision making. In this work, Chain of Thought or COT breaks down complex driving situations into sequential reasoning steps, enabling the PRIMEDrive-CoT framework to explain its thought process. The paper enhances traditional COT by integrating uncertainty measurements with Bayesian models, allowing the system to generate interpretable explanations for actions like braking or lane changes, while highlighting attention to relevant objects through complementary Grad-CAM visualizations. This is the overview of PRIMEDrive-CoT architecture diagram, a precognitive, uncertainty-aware chain of thought reasoning framework for autonomous driving. Post LiDAR-based object detection, we construct a Bayesian Graph Neural Network (BGNN) that constructs graphical object interaction learning and uncertainty based on risk assessment ranking. Shannon entropy for each detected uncertainty object, the qualitative analysis of risk assessment object is color coded as red, high risk, orange, moderate risk, and yellow as low risk, aligning with system's real world decision making and ensuring interpretable scene analysis as shown in figure below. This is a performance comparison of PRIMEDrive-CoT framework with previous state-of-the-art approaches. It is observed that the proposed method has made a notable improvement over the current state-of-the-art methods in speed and path accuracy. Our final decision-making mechanism is driven by object interaction learning and chain of thought procedure. COT is a sequence-to-sequence procedure where every scenario is evaluated with no initial weights, thereby selecting a chain of process according to the current driving scenario. These are the ablation studies that have been conducted: performance on LiDAR-based 3D object detection and effect of BGNN hyperparameter tuning on detection. These are the takeaways from the proposed PRIMEDrive-CoT framework. We have introduced PRIMEDrive-CoT, a precognitive and interpretable chain of thought framework that integrates LiDAR and multi-view images for uncertainty-aware object interaction and risk-aware decision-making in driving scenarios. Modeled vehicle-to-vehicle and vehicle-to-pedestrian interaction using Bayesian Graph Neural Networks, enabling probabilistic relation reasoning under ambiguous and high-risk scenarios. Proposed a proximity-aware risk metric to prioritize high-risk objects based on spatial distance and uncertainty, enhancing real-time safety and decision interpretability. Thank you.